Okay, good morning. This is our first lecture for the course Refrigeration and Air Conditioning, and course code for the same is ME451. And uh, of course, you already know me because I have taught you fluid mechanics. So, for this course, there will be two teaching assistants. One is Sandeep Kumar. He is a PhD student in School of Mechanical and Materials only, and his email ID and phone number is given over here. And second TA is another PhD student, Atis Desta. His email ID and phone number is also given here. Though most of the times I will be directly communicating with you, so as such you will not find much requirement of TAs for any technical doubts. But if there are any issues, say which are not being solved within the classes and beyond classes, you need to discuss, and if for some special things TAs are to be assigned, then you can actually contact them. Now let's talk about the syllabus for the course. So in this particular course, if we go with the LTP scheme, so as per the course module, it is 300. Okay, but what I will do, I will try to follow over here 2.5.50. Okay, so as per the course, as per the syllabus, it is proposed that there will be 3 lectures, no tutorial and no lab. But what we will do, because in this course we will try to solve some numerical problems, so that's why I will try to conduct 2.5 lectures. Like after every 5 lectures, we will try to have one tutorial session where we will be discussing the questions. If you go with the syllabus, so refrigeration, basic introduction to refrigeration systems, method of refrigeration, what is Carnot refrigeration, unit of refrigeration, and COP, etc. That initial whatever nomenclature is required to understand this subject, that we will be discussing. Next unit is on air refrigeration cycle. Basically, in your course of thermodynamics, you study about air standard cycles. Okay, so in case of air standard cycles, our working fluid is air, and there are certain assumptions which these working fluid follows while it goes through different processes in a cyclic manner. And different air standard cycles which you have already studied are nothing but the Otto cycle, diesel cycle, Dual cycle, Brayton cycle, etc. Okay, so all these are the power producing cycles. If we operate in a reverse manner, okay, so instead of producing the power, if we supply some work input, what we can do, we can achieve the refrigeration effect from the same cycle only. So that type of cycles we will try to see over here. Second is vapor compression system. So vapor compression system, basically this is the system which operates in two-phase design. For example, in power cycles you have talked about Rankine cycle. Okay, so in Rankine cycle, water is the working fluid. So water after pumping process is in the subcooled state, and then you heat the water first to reach the saturated state in a boiler, and then in the boiler you convert it from saturated liquid to saturated vapor, and then you superheat as per the requirements, and after superheating, expansion process is done. And again, after the expansion process, it is close to the saturated vapor state, and in the condenser we convert it from saturated vapor to liquid state. So it means whatever the working fluid is there, during the different processes of the cycle, it is changing its phase first from liquid to vapor and then from vapor to liquid, okay, to operate the cycle. And Rankine cycle is nothing but a power producing cycle. Now our task is not to produce power, our task is to achieve refrigeration. What is refrigeration? I will go into the precise definition, but we can simply understand, whenever our aim is to cool something below the ambient temperature, then we call the process as refrigeration. Okay, so in case of refrigeration process, because now our aim is not to produce work, our aim is to cool something below the ambient temperature. To cool something below the ambient temperature, we need to remove heat from that. So for that purpose, whatever system we will be using, if that system is operating in the two-phase design, then that system is called as vapor compression system. So of course, vapor compression system is popularly used in plenty of the practical implementation of the refrigeration and air conditioning systems. So we will be discussing about the vapor compression system in very detail. Okay. Then another type of refrigeration system is vapor adsorption system. So basically vapor adsorption system is kind of another variant of the vapor compression system, where compressor of the vapor compression system is replaced with some additional components, and the advantage is that the vapor compression system utilizes the high grade energy. We need to supply high grade energy to operate the compressor of a vapor compression system. But if we have some low grade energy available, for example waste heat from some applications, we can utilize that waste heat for replacing the compressor in a vapor compression system, and we can achieve the refrigeration by using the low grade energy, which is actually heat. So that type of system is vapor absorption system. We will be talking about this. Other than that, in all the refrigeration systems, we use some working fluid. For example, in air refrigeration system, we are using air as working fluid. In vapor compression systems, if you recall from the older days, then CFCs, okay, chlorofluorocarbons were used. Nowadays, we are replacing the chlorofluorocarbons, and we are trying to use, say, ammonia, we are trying to use R134A, we are trying to use propane, etc. as refrigerants. Okay. So all these working fluids which we use in these systems, these are called as refrigerant. So we will try to see what is the classification of refrigerant, what is the meaning of R134A, what is the meaning of R22, R12. We will try to see their nomenclature, and what should be the desirable properties of the refrigerant. You cannot use any random fluid as a refrigerant. Okay, so refrigerant must have certain properties, then only it will be performing some specific assigned job in a device known as refrigerator. Okay, so we will talk about refrigerants. Then of course there are some emerging refrigeration technologies such as magnetocaloric, electrocaloric or thermoelectric based refrigeration, etc. Of course we will not study about all these systems in very detail, but I will just introduce these as the overview of all these techniques. Other than refrigeration, along with the refrigeration, one term is very commonly used, and that term is actually air conditioning. What is the basic definition and what is the overlap in between the refrigeration and air conditioning, that we will see subsequently. So in case of air conditioning, actually we will try to learn about different processes that we perform while we go for air conditioning. And of course, in order to achieve refrigeration and air conditioning, we connect different type of equipment which perform in certain fashion. Okay. So whenever we combine different equipment, we must have the elementary knowledge about their characteristics and how the individual characteristics are combined together to achieve the system characteristics in a particular manner. Is this point clear? So this is what we will try to do here. Now if we talk about reference books, so CP Arora, Refrigeration and Air Conditioning. So this book is actually written long back, sometimes in 1984, but I think we will be referring to third edition of this book, which came in 2012. So if you want to know about CP Arora, was professor in Department of Mechanical Engineering at IIT Delhi, and he was actually the first PhD in engineering from IIT Delhi. So in engineering, he was first PhD from IIT Delhi. Then we will be referring to another book, Refrigeration and Air Conditioning. Of course, this book came long back in 1981. But what we will try to do, we will try to see its latest edition, and we will follow that. This book is authored by Stoker and Jones. Then these were the books which mainly I will be following in this particular course. Other than these, if you want to refer for your reference, you can use DOSAT, Principles of Refrigeration. You can use R.C. Arora. Again, Professor R.C. Arora was professor in Department of Mechanical Engineering at IIT Kharagpur, and this book was written, he prepared this manuscript sometimes in 2012 when he was fighting against cancer, and this book was published after his death. And then third book you can refer to Manohar Prasad, Refrigeration and Air Conditioning. Again, he was professor in Department of Mechanical Engineering at IIT Kanpur. So in refrigeration, we have a lot of books from Indian authors as well, and all these are very good books, and we can refer. You can refer all these books. Of course, CP Arora and Stoker we will try to follow significantly, and for some topics I will also try to refer RC Arora, and all these books, the top four, these are available in our library. Okay, Manohar Prasad I could not find, but I'll try to propose it in library so that in the next time it is there. Now, prerequisite for this course is engineering thermodynamics. Okay, because in thermodynamics we talk about different things like state of the system, process, cyclic versus non-cyclic processes. Then we talk about adiabatic processes, isothermal processes, isobaric processes, open systems, closed systems. So this type of knowledge will be useful. Then the information about the thermodynamic properties such as internal energy, enthalpy, entropy, etc. So as you people have recently studied the thermodynamics, so I think you will not face much difficulty in understanding. And if you know the concepts of air standard cycles and vapor power cycles, then it's very easy because you only need to reverse the different components to operate the cycle in a reverse fashion. Okay, so as such, particularly for air standard cycles and vapor compression cycles, you should not find difficulty if you have good understanding of thermodynamics, because this is nothing but just application of thermodynamics in some reverse manner. And attendance as per institute it is 80%. Now evaluation scheme, so mostly I will try to give you 3 to 4 assignments at max, and out of these 3 to 4 assignments anyone will be randomly evaluated, and that will be having 5 marks. And of course it is better to practice assignments, because if you practice assignments you will be able to do numerical problems in your exam quite easily. And we will be having 2 quizzes. So one quiz before mid-sem and another quiz after mid-sem. So these will be of 20 marks, and these will be unannounced quizzes. Okay. So then we have mid-semester exam. So weightage of mid-semester exam is only 25 marks. We will be having final exam, which will be of 40 marks, and then we will be having one small project which will be of 10 marks. So basically, refrigeration and air conditioning is actually very important topic, because we use it in our daily life for many things. Okay, in your kitchen you are using refrigerator, in your room you are using window AC, split AC. This classroom is having many AC ducts. Okay, so outside the classroom if you see there is a cooling tower. Okay, so within our campus we are having different type of refrigeration systems over here. So one, we have actually this refrigeration system in this A11 building only, which takes care of the cooling needs of A9 building, A11 building, A10 building, A13 and A14 buildings. Then we have another refrigeration system near A17 building which takes care of the air conditioning, or particularly the cooling and heating needs of A17 and A18 building. Similarly, we have one heating system also, which is some of the rooms in all these buildings only have heating system. So for that we have another separate system. Then other than that, in our guest house if you go, so we have heating and cooling combined system in all the rooms and all the portions of the guest house, but that system is slightly different. That's a VRV system or VRF system. So what is VRV or VRF system, that we will be discussing in detail. So what we will try to do, probably after the mid-sem exam, once we have good understanding of different components and different refrigeration cycles, we will try to have some visit to these systems also. Okay, and here we will try to see how practically different components are assembled and how these are actually installed and working. So we can get some idea of field operations, how refrigeration and air conditioning is being operated in the field, and based on that, maybe based on the field visit and slight extension to say designing refrigeration system or air conditioning system for small room, we can actually form small teams in the group of 3 to 4 students, and then you can actually make small presentation based on that project, and that we will try to take up in this. Okay. Okay, so this is all about the course details. Anyone is having any doubt about this? Now after the course details, let us now start with the course. Okay, so first is, if you see, the title of the course contains two terms: refrigeration and air conditioning. Though I have already given you some idea about the refrigeration, but still, can you, maybe you have already understood, I have already told you. So what is refrigeration? If I have any system whose temperature is to be maintained below ambient temperature, okay? Then the process will be called as refrigeration. The process by which we maintain the temperature of a system or substance or anything, whatever we have, below the ambient temperature, that process we call as refrigeration. Now can you tell me what is the difference between refrigeration and cooling? Basically, if I am trying to maintain the temperature of some substance below ambient temperature, it means what I am doing? I am removing heat from that particular substance, and the process of removing heat from the substance is sometimes referred to as cooling also. Okay, so what is the difference between refrigeration and cooling? Refrigeration versus cooling. What is the difference? Can you anticipate something?
So refrigeration has to be like going to take the temperature below ambient temperature, but cooling need not be always below. We need to take below ambient temperature.
Same. Yes. So that is the precise definition. In case of cooling, for example, you have a hot water bucket. Okay. So water bucket is at, say, 70 degrees Celsius. If you just keep it in the surrounding air, what will happen? Slowly it will lose its heat, and after losing its heat, at next the water can go up to the temperature of ambient conditions. Okay. So cooling is nothing but a spontaneous process. Cooling is a spontaneous process which is occurring by its own, but in cooling we have one limitation, that we can maximum go up to ambient temperature, because in a spontaneous manner you can at max reach up to ambient temperature, you cannot go below the ambient temperature. Okay. However, in refrigeration, in certain cases our requirement may not be to go below ambient temperature, but in certain cases, if it is there, always our attempt is that we can go below ambient temperature. Another important point is, if you have to maintain something at below ambient temperature, what it means? For example, this is the room. If this room is, say, at 15 degrees Celsius and outside ambient temperature is at 25 degrees Celsius, what will happen? What is the spontaneous process? The spontaneous process is, you all have studied heat transfer. The spontaneous process is, energy will transfer from high temperature to low temperature. So it means there will be some flow of heat from outside to inside. Okay, and this heat will keep on flowing across the walls of this room unless or until the inside temperature is becoming equal to the ambient temperature. Because ambient is a thermal reservoir, we have infinite amount of heat over here, so its temperature will not decrease upon removing the heat. Is this point clear? Now, but our interest is that this room should be maintained always at 15 degrees Celsius. So how this can be achieved? This is only possible if whatever the amount of heat leakage which is coming from ambient to the room, I can remove same amount of heat from the room. Okay. So what I will be doing now, whatever this heat is entering, this entire heat amount I need to remove from the room, then only I will be able to maintain the room at the same condition. If I can say that from this across all the walls, overall Q in amount of heat is coming to the room, and if Q out is the amount of heat which I am removing from the room with the help of some external device, then Q in has to be equal to Q out, then only I will be able to maintain a temperature of 15 degrees Celsius within this particular. Is this one clear? So of course, whenever we are transferring the heat from 15 degrees Celsius, somewhere we have to dump this heat. Ultimately, again we will be dumping this heat into the surroundings only. So here, this Q out amount of heat we are removing from cold substance, and we are transferring this Q amount of heat to a where hot substance, okay, or hot ambient. So to do this process, one has to supply certain amount of water. This is not possible. Heat cannot spontaneously transfer from low temperature to high temperature. So basically this is nothing but refrigeration.
जैसे अभी 50 डिग्री टेम्परेचर है इसका अंदर तो अगर 24 डिग्री पे मेंटेन है तो भी वो रेफ्रिजरेशन मतलब 24 डिग्री
Yes, then also it's refrigeration. Okay, whatever is the temperature, it has to be below the ambient. Is this one clear? So this is refrigeration, and this is the difference between refrigeration and cooling. So cooling is a spontaneous process. Here heat will be transferring by its own, but in case of refrigeration, because we have to maintain something below the ambient temperature, so in order to maintain it below the ambient temperature, we have to transfer heat from low temperature to high temperature. This process cannot be spontaneous. We have to supply certain amount of work input in this process. Is this one clear? Now, along with the refrigeration, there is one more associated term. What is this term? Air conditioning. Now, can you tell me what do you mean by air conditioning?
To maintaining heat, we can also maintain humidity and air quality through air conditioning.
Yes. So basically, in case of air conditioning, first point is very clear, we are doing the conditioning of the air. Okay. And mostly conditioning of the air is done first for thermal comfort. For example, if you are sitting inside this room, so for human, what is the desired temperature? 22 to 23 degrees Celsius, around 23 degrees Celsius. And in situations when you see that temperature is low but it's very humid, then also do you feel comfortable? So it means there is some optimum value of humidity which also has to be maintained. What is that optimum value of humidity? For human comfort, how much percent relative humidity? Say we give the range of relative humidity from 0 to 100%. Of course, what is relative humidity I will be defining subsequently. But if you have heard, because always if you see Google, some weather forecast or some this one weather station, their temperature, relative humidity 90%, 80%, 20%, it is specified. So do you know what is the number required for human comfort? It is close to, temperature is 23 degrees Celsius and relative humidity is close to 56%. Okay, so that is something which is needed for human comfort condition. Now, let me consider that I put you inside a room where AC is working fine. Okay, I have put you inside a room for 24 hours and AC is working perfectly fine. It is giving me temperature of 23 degrees Celsius and relative humidity of 56%. But I have perfectly sealed the room so that No air from ambient can come inside the room. Okay, and I am not doing any recirculation of the air from ambient. I am just keep on cooling the room air only for a long duration of say 24 hours. Will you be finding it comfortable? Why you will not find comfortable? Yes, after some time what will be happening? It will be having more amount of carbon dioxide. Okay, so we require some optimum air quality also. Okay, so it means that I have to also perform circulation. Okay, other than that, if I add some dust particles in the air, will you be finding it comfortable? So it means along with that I have to also clean the air. Okay, so in case of air conditioning, one has to achieve four tasks. First is one has to control the temperature. Second, one has to control humidity. Third, air quality. And fourth is, yes, quality circulation, that is coming over here. Cleanliness. Air has to be clean also. Okay, so in your AC, it is not only that there is a fan which is just circulating the air. If you see in your AC, there are some filters also. If you see window AC or even the split AC, there are some filters. What these filters do, when air passes over the filters, these try to catch the dust particles so that it can clean the air also. Okay. Now, over here, can you tell me where do you find applications of air conditioning? First is in room for human comfort. Okay. Is there any other application?
Cold storage.
Cold storage. Okay.
Cold storage.
Yes, cold storage.
More
Mall में. Okay.
more जापे dead bodies are.
Okay. Dead bodies. Okay. So the point is why refrigeration and air conditioning is actually always placed together. That let's try to understand. If you talk about only the refrigeration, refrigeration is the process. Ultimately, we may have some requirement that I have to maintain air at say temperature below ambient temperature. That is my requirement of air conditioning during the summers. What I need to do, I need to maintain, because this temperature is actually not favorable for the thermal comfort, human thermal comfort conditions, so I have to cool the air. Okay, I have to also maintain humidity, and in summers, sorry, in winters, what I need to do, in winter surrounding is cold. Okay, so in winters I need to increase the air temperature above the ambient temperature. So basically all these things are nothing but comes under the horizon of air conditioning. Now can you tell me what is the application of refrigeration? Refrigerator. So refrigerator is actually, okay, maybe used for food preservation. Anything else? One application is food preservation. Anything else? Refrigeration is required in various industrial systems for doing different tasks. Yes, industrial systems for cooling of workstations or, sorry,
Condensers or
power plants. Anything else? There are plenty of applications of refrigeration as well. So this is nothing but, this portion is where you are not conditioning the air, but mainly you are trying to focus on some specific job which you need to cool below the ambient temperature. Okay. Now, in this portion, when we have to achieve this air temperature below the ambient temperature, we have to follow some process, and that process is nothing but refrigeration. So I can say that along with these application, refrigeration also include this portion. So this is the intersection of refrigeration and air conditioning. Is this point clear? This particular zone is nothing but the intersection of the refrigeration and air conditioning, because refrigeration is not only limited to conditioning of the air. Refrigeration has other plenty of applications. For example, if you go to your supermarket, you will be finding there is some frozen peas. Okay, so all these are actually frozen. Why these frozen? So that you can preserve the food for longer duration. Okay, then in many industries, for example, if you talk about petrochemical industry, you know that the raw oil and natural gas, whatever you are extracting, it's a mixture of multiple fuels. Okay, so if you take out raw oil, in raw oil, kerosene, wax, diesel, petrol, everything is a mixture. Then what we do? We go for fractional distillation process. What we do in distillation process? We try to bring the mixture to different temperatures, and each of the constituent of the mixture has their different boiling point. Because of that, they comes to liquid state, and we can segregate, keep on in a sequential process, one by one we can segregate the different components. So for that we have to achieve the boiling point of different substances. So once we need to achieve the boiling point of different substances, it means we have to perform the process of refrigeration. Is this point clear? So refrigeration is having actually application in beyond the air conditioning. But of course, particularly the portion of air conditioning which we use in summers, there also one has to do the refrigeration for achieving that process. So that is where we see the overlap in between the refrigeration and the air conditioning. However, in the earlier days, starting, what we used to do, we used to actually use direct electric heaters, electric resistance heaters, for achieving this condition during the winters. But what nowadays we are using? If you see nowadays, instead of putting the AC only for cooling conditions, there are ACs in the market which are dual purpose ACs, which are used in both winters as well as in summers. Okay, so it means that basically if you have to maintain air at temperature above than the ambient temperature, then what you need to do? What do you need to do? You need to add heat. Okay, so once you are adding the heat, one way of heating was using an electric resistance heater, where you have placed some heater coil and then you have plugged it into the electricity, and that heater is giving you the heat. Nowadays you see that we are having these air handling units which can even supply the hot air. So basically our refrigeration system is equipped to function in a fashion so that it can serve the purpose as a heat pump. Okay, so it can use, refrigerator can also be used as a heat pump. So that's why now the extent of the refrigeration is even extended for the heating applications. Okay, so that's why we can say that air conditioning is a small portion of the refrigeration. Air conditioning is a small portion of the refrigeration, whereas refrigeration has wide horizon. Beyond air conditioning, it is used for many other purposes as well. Is this point clear? Now, if I ask you to categorize what could be the applications of refrigeration and air conditioning? Of course, some idea I have given you, but if you have to make proper categorization, so very first application we have seen is air conditioning. But whatever the air conditioning I have now introduced to you, this air conditioning was only big emphasis for human comfort. Okay, so it means first is to achieve the human thermal comfort conditions, and in order to achieve human thermal comfort conditions, the refrigeration and air conditioning is used in office buildings, where wherever you are having people. So in all the buildings where you will be having actually uh, spaces for human, there you have to actually employ this. Another is industrial systems. So in industrial systems, one industrial system I have already introduced you, which is nothing but the petrochemical industry. One industrial system I have already introduced, which is petrochemical industry. Other than petrochemical industry, anything comes to your mind? Textile industry. So in textile industry, the yarn, okay, individual thread, whatever is fabricated, it is extremely sensitive. It is extremely sensitive to air speed, air, what else? Humidity. It is extremely sensitive to humidity. Okay, so that's why in textile industry one has to significantly focus on the quality of air which we are using. Any other application? Construction industry. Can you tell me what could be the application in construction industry? Sorry? Air cleaning, okay. Anything else? If only air cleaning is there, all the four things are not done simultaneously, then it's not basically air conditioning. In construction industry, whenever we perform the excavation process, okay, so sometimes what is done, a portion of the land is basically frozen so that excavation can be done easily. Okay, so even freezing is performed before excavation in certain conditions so that you can do the controlled excavation in an easy and efficient manner. Okay. Anything else? Third very important industry which is associated with this is food preservation and processing. So you have many dairy plants. Okay, so in dairy plants you do the processing of the milk. So for processing of the milk you have to go to different temperature conditions. For that refrigeration and air conditioning is needed. You have to preserve the foods for longer duration. For example, frozen vegetables, frozen meats, okay, frozen fruits, etc. Then cold storage units. So in food preservation and processing, you do different types of tasks. One is processing of the food items, second is freezing of the food items, then third is transportation of the frozen food items. Okay, so for example, if frozen food items are stored at one place and say these are stored in Chandigarh, okay, but you want to distribute it in the mandi, then you must have a vehicle which can actually take all these frozen items in the frozen state itself from Chandigarh to mandi, and then in the mandi it should be stored in a store, and in our household also till the time we have not used the frozen items we have to keep in the frozen state. Okay, and whenever we want to use, then we will be actually defreezing this. So all these entire things are coming under this. And point number 4 is miscellaneous applications. Now, can you tell me Any single example of miscellaneous applications? There are hospitals, yes. So industry, you can bring it in the hospital industry. Very important example. Space vehicles, okay. In miscellaneous applications, of course, you can fit in all these things which are not included in the broader sense. Other than that, say you are a researcher, you are trying to do some research on some material testing, and you have to test material at minus 50 degrees Celsius, minus 90 degrees Celsius. Then what you need to do? In your research application, you need to develop some experimental facility, you need to develop some chamber which can maintain the temperature condition up to the desired level. Okay, for example, all these superconductivity experiments are being done at very low temperature conditions. Okay, so for achieving all these tasks, you have to employ the refrigeration and air conditioning. Okay, maybe one another, with this I recall one important point. The refrigeration can also be clubbed together with another important term, cryogenics. But before that, let me also include one more part in air conditioning, which is actually distribution of air. So distribution of air also comes in the air conditioning only. For example, what do you mean by distribution? For example, this is a room which I need to condition, and I have only placed one say air handling unit here. So what will be happening? That air handling unit will be cooling this particular portion of the room, but that other corner of the room may not be at the desired condition. So it means this is a poor distribution of the air. For example, in heating systems, in heating system, you have placed all the distribution duct of your air handling system on the top portion. So what will be happening? Whatever the hot air supplied by these portions will be collected only at the top. You will not be finding, and below portion will be actually cold. Okay. So if you have to place the air distribution duct for a heating unit, that has to be placed somewhere on the bottom, so that hot air is supplied at the bottom, and when, because of density, it will try to move in upward direction. During that process, it transfer heats and becomes cold. Is this point clear? So distribution of air is very important. Say in the cooling environment, I have used a duct, and I am having huge amount of flow rate, and that duct I have placed just above a single person. So what will be happening? If I supply cold air only to focus entire cold air only on you, what will be happening? Will you be feeling comfortable? So it means that for making the comfort condition, distribution of air also has to be designed. Is this one clear? So that's why distribution is another important term which we should include with air conditioning. Now, I have told you one another term, cryogenics. So now let me put the name refrigeration versus cryogenics. Can you tell me the difference?
Where material shows some unique properties like preservation of biological samples.
Okay, so let me give you some idea. Refrigeration, whenever we maintain the temperature up to minus 60 degrees Celsius, that comes under the term refrigeration. If I go to any temperature ranging from minus 60 degrees Celsius, what is the limit? Limit is absolute zero temperature. Okay. So if I operate in the range from minus 60 degrees Celsius to absolute zero temperature, during that time, of course, I have to use the same refrigerating unit with large number of multi-staging or so, but the process will be referring as cryogenics. Okay, and cryogenics has many applications, one of which, say, preservation of biological samples, and other than that, it is also significantly used for liquefaction of gases. Liquefaction of gases and separating different constituents from a gas mixture. Is this point clear? For example, in air, you have carbon dioxide, you have nitrogen, you have oxygen, major constituents. Now, if you have to extract pure oxygen out of the air, what you need to do? You need to keep on cooling the air. At one point of time, liquefaction temperature of one gas will be coming. You cool further, you separate that gas. Now you have only two gases in the mixture. Go to further below temperature. Second gas's liquefying temperature will be achieved. It will be liquefied. You will be having the third gas. If that is also required in liquid stage, then you have to further decrease the temperature up to the temperature. For example, in many oxygen plants which we use in, so oxygen has significant requirement in hospitals. Okay, so in hospitals, typically the liquid oxygen plants are actually employed. Okay, so their temperature goes up to the liquefaction temperature of the oxygen close to minus 170 degree Celsius. Okay, so all these things comes, of course, under the broad horizon of refrigeration, but at that particular condition we call the application, we call that particular process as the cryogenics. Okay, is this point clear? So are you clear with what is the need of application, what is the need of refrigeration and air conditioning? So refrigeration and air conditioning is actually very integral part, and of course if you have to go up to these temperature conditions, always our attempt should be to design the energy efficient systems. That should be our attempt. Okay, because with the growing population, always we hear this news that our fossil fuel resources are depleting. Okay, we have to shift to renewable energy resources, and then other than that, we have major challenge nowadays is environmental challenge. Okay, another major challenge is environmental challenge. We nowadays we say that CFCs, maybe you don't know very much about in detail about their properties, but one thing we all know now because of the global warming concerns and the environmental concerns, that our ozone layer is depleting. So CFCs were the significant contributors for depletion of the ozone layers. So nowadays we are designing the systems where we are actually not using the CFCs as refrigerants. Okay, so energy efficiency and environmental challenge, in addition to one more constraint, which is cost, which comes from economics. Okay, maybe you have made extremely energy efficient system, extremely environmentally favorable system, but the cost of your room AC is 1 crore. Will people be able to purchase that? People will not be using. You have made it energy efficient, you have made it environmentally efficient, but people will not be able to afford it. Okay, so that's why we have to also keep into mind all these three parameters simultaneously. Of course, we will not be able to optimize each parameter, so somehow we have to consider the overall optimization so that we can propose some design which is energy efficient, environmentally, it is overcoming the environmental challenges, and it is also cost effective. Is this point clear? So maybe with this we will stop, and in the next lecture we will talk about brief history of refrigeration, how in the past people have employed refrigeration, and then we will slowly shift towards the understanding of modern refrigeration system.